Well, sometimes we have like exponential expressions involving factorization, like in these cases. Okay, so let's start with question 1. We have like 2 to the x plus 2 plus 2 to the x plus 3 all over 12 times 2 to the x. Now to solve this, we need to break down the terms. Okay, now let's say please note that we cannot simplify these 2 to the x with the 2 to the x denominator yet. No, we cannot do that, but we can break 2 to the x to the power of 2. It can be written as 2 to the x times 2 squared. Okay, and then also 2 to the x times 2 to the 3. I'll prove it to you now why I'm saying that. And then 12, I prefer just so long to write in terms of its prime factor. It's gonna be like 2 squared times 3 times 2 to the power of x. Now, remember the law of exponent that says a to the m times a to the n equal to a to the m plus n. These laws are useful both ways, okay, from left to right as well as from right to left, as you can see there. Okay, so we can we have this form which is on the right, 2x plus 2. So we break it up into this other form on the left, a to the m times a to the n, so 2 to the x times 2 to the 2. Same also over here, and then at the denominator, 12 is not a prime number. I prefer to write 12 in terms of its prime factor. It is 2 squared times 3. Now that we did write it this way, we note that we have like the presence of 2x here, and then 2x in the terms, in the 2 terms, because the sign plus makes the numerator two separated terms. Okay, this is a term, that is a term, this is a term, this is another term. Now 2x there, we can take 2x as a common factor. Okay, so it can be taken as a common factor, 2 to the power of x, and now we can open brackets and then close bracket there, and then all over 2 to the power of 2 times 3 times 2 to the power of x. Now if I take 2x as a common factor, we are left with 2 squared plus 2 to the power of 3. Now notice that now we have one term at the numerator, because all this makes a term. It's a product. Okay, 2 to the power of x times what is in the bracket here. This makes a term. Now we can simplify. We can simplify 2 to the x here with the 2 to the x there. Okay, then we in the brackets we have like 4. 2 squared is 4, and then 2 to the power of 3 is 8 all over 2 squared is also 4 times 3. So then this is like 4 plus 8 is 12. So 12 over 12 is just equal to 1. Okay, that's the answer for question 1. Okay, I think I need to do question 2 as well. It's similar to question 1. Just for sake of clarity, I need to do question 2 also. Question 2 was 3 to the power of x plus 1 plus 3 to the power of x plus 2 all over 8. 8, I prefer to write 8 in terms of, okay, 8 multiplied by 3 to the x plus 1. Now let's solve it. You may notice that there is a 3 to the power of x here, and then 3 to the power of x plus 1, 3 to the power of x plus 2, 3 to the power of x plus 1 there. Now this is what I can do. Excuse me. We can write this as 3 to the power of x plus 1, okay, plus 3 to the power of x plus 2. It's just one more than x plus 1, okay? So over here, I can write it like 3 to the power of x plus 1 times 3 to the power of 1. Knowing that if I combine the two, I will get 3 to the power of x plus 2, according to the formula here, this formula in red, okay? It will give me 3 to the power of x 3 to the power of x plus 2. Now, at the denominator, over here at the denominator, we have 8. 8 is 2 to the power of 3. I prefer to write it in terms of a prime factor, to the power of 3, multiplied by 3 to the power of x plus 1. Then we have 3 to the power of x plus 1, 3 to the power of x plus 1, and 3 to the power of x plus 1. So now I can take 3 to the power of x plus 1 as the common factor here, okay? At the numerator. Now, if I take this 3 to the power of x as a plus 1 as a common factor, we're left with what here? Nothing. No, there is a 1 here. Invisible 1 is there, okay? Plus 3 to the power of 1, which is just 3, okay? Let's just move this a little this way because of space. Okay, and then over 2 to the power of 3 multiplied by 3 to the power of x plus 1. Okay. Now that we have like, this is a term, this is a product, so numerator is a product, this is a product as a denominator, we can simplify 3 to the x plus 1 and 3 to the x plus 1. And then there we have like 4 over, okay, I don't see the need of keeping 2 to the power of 3, I can just leave it as it was 8. And then 4 over 8 is just equal to a half. Now let me go over it a little bit. First of all, I've noticed that this is the bases here are the same, but I cannot simplify here, okay, yet, because these two, the numerator here, we have a sign plus, it's not a times, okay? The sign here is the sign for product. Actually, for the addition, it makes two terms, okay, or different terms. This is a term, that a term, so I cannot simplify it. If it was times, I could simplify this with that. But it's a plus here, so there are two terms. I cannot just simplify the way I wish. So what I can do, we reduce 3 to the x plus 2, we make it like 3 to the x plus 1 times 3 to the power of 1, knowing that all this, okay, all this makes 3 to the power of x plus 2. Okay, now that we have this, we can take 3 to the power of x plus 1 as a common factor, and then we can simplify, and then we're left with 4 over 8, which is equal to a half. Okay, question 1 and question 2 are much similar, and even question 2 also. Question 3 is similar to question 1 and question 2, so I prefer to leave this one for you to practice, and then we will do question 4 now. Question 4, right here. Five to the x plus 4 minus 5 to the x plus 3 all over 100 multiplied by 5 to the x plus 1. Now, over here, I see that we have x plus 1, x plus 4, and then x plus 3. The bases are common. Now, what I can do, I can write 5. I can break this one into 5 to the power of x plus 3 times 5 to the power of 1. Knowing that this, I meant to say plus 1 multiplied by 5 to the power of 3. Knowing that this combined makes 5 to the power of x plus 4. Okay, same also over there, it's minus 5 to the x plus 3 can be written as 5. Excuse me. This would be like 5 to the x plus 1 multiplied by 5 to the x, 5 to the 2. These two, the product of these two combined will make 5 to the x plus 3. Then all over 100 multiplied by 5 to the power of x plus 1. Now, the strategy was to have this, okay? This, and then that. Now we can simplify. We can take 5 to the x plus 1 as the common factor, okay? All over 100 times 5 to the x plus 1. So here within the bracket, we have left with 5 to the power of 3, which is 125. And then 5 to the 2 is 25. And then this will be what we can simplify this and that. And then we have like 100 over 100, which is just 1. Okay. We can do question 5. The question says 4 to the power of x plus 3 times 2 to the power of 2x plus 1 all over 7 times 2 to the 2x plus 1. Now, what can I do here? I don't really see a common thing to simplify yet, but there is this question, this basis 4 here, okay, it's not a prime number. 4 is not a prime number, so we need to reduce 4 in terms of its prime factor. It was 4 to the power of x, so we can write here 2 to the power of 2, okay, which is 4 in terms of its prime number. So plus 3 times 2 to the 2x plus 1 all over 7 times 2 to the x, not to the x, but to the 2x plus 1. Now, this makes what? 2 to the 2x plus 3 times 2 to the 2x times 2 to the 1. Okay, I can simplify this now. 2 to the 2x plus 1 can be written as 2 to the 2x times 2 to the 1. Okay, over 7 times 2 to the 2x, 7 times 2 to the 2x multiplied by 2 to the 1. Okay, so I wanted you to notice that first I break down 4 to that, okay, and now this time I also break down 2 to the 2x to this, and then the denominator here also to that. The strategy was to have like a common factor. Like now we have a common factor. If I look at the denominator now, the common factor will be this value here, 2 to the 2x, 2 to the 2x, and 2 to the 2x there also. So we can take it out as a common factor. Okay. Now we can take 2x, 2 to the 2x as a common factor, and then this is what will happen over 7 times 2 to the 2x multiplied by 2. Okay, there in the brackets, in the bracket should be, if I take 2 to the 2x out, the answer here, it mustn't be 0. Okay, understand that it is, it can be like 1 times 2 to the 2x. Okay, so the answer here is 1 actually, when we take 2 to the 2x out as a common factor. So multiply plus 3 times 2. Okay, now we can simplify 2 to the 2x and 2 to the 2x. And then 3 times 2 is just 6, and 1 plus 6 is 7. So we have like, we have now 7 over 7 times 2. And now we can simplify again the 7, and then the answer is just equal to a half. Okay, that was question 5. The same way, I would like to let you do question, maybe let's do question 6. Okay, question 6. We do have like 3 to the power of x to the power of 2, like that, minus 9 to the power of x minus 1, all over 9 to the power of x minus 1. Okay, now note that you cannot simplify these two. You cannot do that. No, it's not mathematically correct. So what we can do here is we can transform 3 to the x plus times 2. We can make it like, okay, this time we don't need to reduce 9 in terms of the prime factors, because I know I can make this one 9. When we can see the power of 2 there, okay, we can just make it like this makes, okay, let me highlight it. This part here is same as if we did 3 to the power of 2 to the power of x. It is correct according to law of exponents. Okay, we can, multiplication is commutative. We can do x times 2 or 2 times x. Okay, still correct. And then that's equal to 9 to the power of x. So we can make it like 9 to the power of x, okay, minus 9 x minus 1 over 9 to the power of x minus 1. Now, we need to find a common factor. We can break this into like, we can break this into like 9 to the x minus 9 to the x minus 1 can be written as 9 to the x times 9 minus 1, okay, all over 9 to the x times 9 minus 1. We can do this way, and then if we take 9x as a common factor, this will be 9x as a common factor. It's going to be like over 9x times 9 to the negative 1. There in the brackets will be like 1 minus 9 to the negative 1. And then we can simplify 9 to the x, 9 to the x. And then this will be 1 minus 1 over 9 over 1 over 9. Okay, and then 1 minus 1 over 9, this is equal to 8 over 9 over 1 over 9. The law says that if you have a fraction, divide by another fraction, we multiply the first fraction by the inverse of the other. And then this will be equal to 8 over 81. Okay, this is one way of solving this. Or alternatively, we can do this. Because we have like 9 x minus 1 here, x minus 1 there, or from here, maybe let's just do, from here, we can do this. Let me write it over here. Get like 9x minus 9 to the x minus 1 over 9 to the x minus 1. We could say, I can write, look at this 9 here, 9 to the x here. I can break it up into something like 9 to the x minus 1 times 9 to the power of 1. Knowing that the two combined, we're just gonna make 9 to the x, okay? Just gonna make 9 to the x. Now, minus 9 to the x minus 1 all over 9 to the x minus 1. Now, I did that because I wanted to take this, okay? And that as a common factor because I know this. So this can be then 9 to the x minus 1, okay, in the bracket like that. over 9 to the x minus 1. So now in the bracket, I can just write 9 minus 1. Okay. So there we can simplify this and that, and the answer is 8. Okay. Let's see what we did wrong here. Because when we simplify there, we just got we have left with 8. But got 8 over 81. What was the problem? When we break this into 2, we have 9 to the x times 9 to the negative 1, and then we simplify this, and it's gonna be 1 minus 9 to the that makes 1 over 9, and that also 1 over 9, and that will be 8 over 9. And oh yeah, that was a mistake. We multiply by the inverse of the other fraction, okay? Not by 1 over 9, but by 9 over 1. And then the answer is just 8. Because 9 and 9 will be simplified, and the answer will be 8 here. Same as here. Alternatively, we can do that. Okay. So the same way we did question 6. You can also go over and do question 7. They're really similar. Question 7, even question 8 and question 9. So maybe I'll leave 7 and 8 for you to practice. And then I can just do question 9. Okay. Oh, yeah, no, I'll leave 7, 8, and 9 for you to practice, just the same way we did. So do 7, 8, and 9. Thank you.